Welcome back, programming friends. Almost each day brings a new challenge, and today's Leetcode problem is no exception. Let's solve it together. So today we have same tree. Balanced tree, binary tree was solved yesterday. So is it the same tree or not? The problem is understandable. So it sounds really easy. We need to check if all the values of each node are the same. So let's and the structure should be identical, but we will, how can we check it? We check it by traversing both of the trees at the same time. So var is same tree, P and Q trees. Probably it won't be easy, but let's try. So what we have, how can we, let's consider about approach. We can traverse one of the three. At the same time, we have this link on the node of second tree, and we check if some value is not the same, then we return false. And how can I check the structure? Well, it's not easy. It sounded easy, but now at least it is not trivial. Trivial. Let's try to make some code. So is same, let's assume that they are the same. As usual, I like to solve it with recursion and some callback function something and traverse PQ callback and return is same. Let's write traversing method. Function traverse PQ callback. If no callback PQ, then exit from traversing. Otherwise, what we do, we recursively call traverse on left subtree and right subtree. Traverse P left, Q left, callback. Sorry. Also, we go, or that's it. Probably it is. Also, if no P and no Q, then also we return. Sorry. No, not this one. If both are finished, then we return from traversing. Callback. Let's say, let's name them mn and try to realize if mval not equal to nval is same false, return false. If not m and n, is it valid, or m and not n, and then the same. Also, and return true on every other case. Let's try to run. What is the problem? M could be null. If not m and not n at the same time, then return true. And we leave this check. If one of them, if both of them is null, then it's okay, we return true. If one of them is still null, then we return false. And here both of them should be not null. Yes. Accepted. Let's try to submit. Accepted. Yeah, it was easy. This was easy one. There are pretty lot of solutions. I don't like to use Q method, but probably I need to try it. I need to learn to remember the way with to solve solutions with queue or with stack. So let's say we have some tree. We can solve it easier by putting both of the trees into the array, and then by comparing them. Interesting. So tree node is some function. And Q should help us, should help me. Let's try to make an approach when we let's watch an examples. Yeah, let's put the each tree to the array like this array, and then compare those arrays by length first of all, and after by content. It should be easier. So I don't need traverse method. I need, how to say, var trees array. Not build tree, not build. Tree to array p q tree as array. If tree as array length does not equal q tree as array length, return false. Var is same true for how can we compare it? Var I equals 0, I less than t3 as array length, I plus equal 1. If this value does not equal this value, is same while is same or what I do is I don't need, if we see that it is not the same, then we don't need to traverse until the end of tree, so we can finish faster. Or I less than this value, do something. Increase I by 1 each time. Yeah, and return is same. So I need to write function tree to array node if not node return empty array. Var q node initially. Var result is empty while q length. What we do? Var L equals to q length for var I equals to 0, I less than L, increase I, etc. Result push what we push the result. Q val, Q val or null. Also Q push Q left, Q right subtrees. How can we how I would stop return result? I need to stop at some point. At which point I need to stop if at any level we have only null nodes. How can I understand it? I don't know. I need to watch previous solutions or submissions. Was it with Q? No, it was recursion. Probably someone solved it with Q. While not empty, size If we have something, then we push it. If we don't have anything, we don't push it. Probably it shouldn't work if Q left. No, not Q. Sorry. Sorry. QI val. We work with ice item. If QI right item, then result Q push Q ice item right subtree. And let's fix it here. I don't need this one. Something like this. Let's try. Out of memory. I don't pull current item. Q shift. I need to shift it after working with this, with it. Oh my god. We take first item and work with this item. My mistake is I need to work with current node, not with item with index. Current node, because indices are shifting. This loop I need only to count items, but not to get items by index. Let's watch what is my error. Console log P3 as array and Q3 as array. One, two, three, 1, 2, 3. They are the same. Why I decided that they are not the same. Now it works. Should work. Why it don't work? I increase I have I. if items is not equal, then we stop. Aha, I need to do to change it. Yeah, this is the case. How can, when I don't, which I don't cover in here. So I need to understand how can I, where is it? How can I get this kind of view, this kind of representation of the tree? How can I do it? Let's say we have the node, and if we have node, then at each level of tree, if we have at least one node, then I need to continue. To continue and fill in the items with nulls. If at some level, not the nodes, but the information that some of the nodes has the nested subtrees. Okay. So I need a flag var has subtrees and initially is false. Then we go through current level and put them, and if we have any subtree, then we do it. We true. Then after this loop we add we make it again as subtree false. I make subtree false in the beginning of this. So subtree false, subtree true, q length, and has subtree. Then do it. Also, we push the current node anyway. So the child of current node anyway. We just calculate we just make calculations about it to subtree or yes. and this is how I can put it. Current, current node, then current node val. Otherwise, okay. If current node, then do what you want. Something like this. Else, what we do else? Else we do result push null q push null null. Also, I can do it like this. Yes, let's try to run. It works. Let's remove console log. Let's remove console log and submit it. Probably it is not performance solution, but yes, it's horrible, but it works. It works with Q. So let's watch other users solutions. I see something visualization of recursive depth first search. It is recursion. We have it, we have done it, and it is Python. Okay. Find true cases. What do you mean? It is Python again. If p and q and p val q val return again, and it is recursion and it is clearer than mine. I like it. It's pretty much clearer. I like it. I need to test it. It should work faster than mine. P left. It don't have any additional variables. Wow. Runtime, I don't know. I guess is not best, but it don't consume a lot of memory. I like it. It's interesting. Let's continue. It was interesting. Recursion, C++, same tree, Java, is in Java, JavaScript, preorder. Preorder traversal. Status true, return status, preorder. It is recursion. It is recursion. Nothing new. Do you have iterative tag? Interactive. What is interactive? What do you mean? O1 space complexity. Traverse PQ, return result. Recursion, I don't know how it can be. What do you mean by interactive? What is brain teaser? What you mean? Is same tree? While not empty SP. Stacks. It is with stacks. Okay. Do you use recursion? No. You have queues for each of the trees. If while one of them is not empty, while one of them is empty, return false. Okay, then take something from the top of the stack. If oh my god, brain teaser. If first is null and second is null, how can I read this condition? Oh my god. If current from the first tree is null, and this is not equal to the fact that the second tree's current item is null, then return false. Then you remove item from the stack. If pcure is null, then just continue to the next iteration. Otherwise, again, oh my god, I don't like this solution. Q linear time and space complexity. Let's show me the code. Is same tree, we have two queues, we take first item for each queue. If they're null, then we do nothing and continue. If one of them null, that means that which means that the trees are not the same, then return false. If value of one of them, if their values are not the same, then return false. Otherwise, push to the queue to the same positions. Nodes to the same positions. Which language it is? C++. Okay, so that's it for today. Good job today. Good job everyone. We tackled the easy one. Make sure to subscribe for more live coding sessions. Take care and happy coding. Bye.